Hello, my name is Sean Ernest. Welcome to my Week 5 summary video. This video we're going to talk about what's been covered in the first 3 weeks of the class. So starting back in Module 1, explaining virtual machines, kernels, file systems, architecture, and hardware components. Virtual machines are basically a computer running inside of another computer. The host, or the computer that it's running on, sees it as just a program to execute. The guest, however, has emulated hardware assigned to it that you can configure, and it sees it as being its own little computer. This is unique in the fact that both machines can kind of talk to each other, but they don't see each other the way that they actually are. The kernel is the most basic of basics. It's the commands that allow you to do what you need to do by assigning resources, making system calls, and choosing what app gets to use the processor and when. You see that it's right next to the hardware layer in our little diagram here. The file system is the order in which the files are stored on the drive. Who owns what directory? This is normally kind of a tree. You see it as files and folders. But ultimately it's basic. It's just where everything is. It also identifies where on the drive each file is stored. Architecture is a way of describing how the components are arranged and will fit within an enclosure. You've got a couple of different primary architectures. ATX, mini ATX, micro ATX are just a couple examples. Hardware components can be broken down basically into 4 major categories. You have your input devices, your output devices, your storage devices, and your processing devices. The input is how you physically interact with the machine. This might be a keyboard, a mouse, a microphone. The processor is what actually does the computing. When you tell it to do something, the processor does all the work. The output could be a display, a printer, a pair of speakers, and the storage is where you eventually save that what you actually want to keep. Oftentimes these are physical hard drives. Nowadays we have solid state drives and things of that nature. This is just a brief overview of a virtual machine setup. So this is my VMware Fusion dashboard. As you can see, I have Windows 10, Windows Server, Ubuntu, CentOS, Chromium, and React. These are all computers that believe they're standalone computers, but to my Mac, this is just a big program that uses a lot of resources. Each one of these machines, you can customize their resources here. So you can customize how many processors in memory, their display, their hard drives, their network adapter, and everything individually so that they see a complete computer setup when you're done. Now, moving on to Module 2, we're going to talk about the command prompt, some commands, viruses, malware, users, and groups. Command prompt is a place that a user can input text-based commands. They look the same across all of the different operating systems. They're usually a box with just a couple words, and they run similar commands across the different systems as well. So, for instance, a Mac user can learn half a dozen commands that they can execute and do similar tasks as they can do on a Linux machine by similar commands. There's just a couple of wording differences. The Windows commands are a little bit different too, but all in all, you can remember just a couple of sets of commands, and you can go to any computer and do just about anything you want to do pretty quickly and efficiently. The commands will range from a simple list or clear command to a complex command like format disk and create users or assign group permissions. But all in all, they allow you to do the same kind of things. Viruses are a specific type of malware, usually designed to replicate within your files and often designed to capture your information. They're just like the flu. They see an opportunity, they spread, and they spread. And eventually they take over your entire computer to where you don't have functionality anymore. Malware is any unwanted and often malicious software Malware is usually designed to capture your information or keep you from using your files until you pay a price. There's a couple of big malware events that we talked about during Module 2. One of them was the triple threat that happened. We talked about how that used a couple of different exploits to capture information, and then deny service. That's all malicious. That's all malware. Users are accounts that each person kind of gets their own little environment that they can customize, and they have a space that they can work in. They can change colors, they can change fonts, they can save files and store files and access other files and work with the programs on the machine. But ultimately, they're relatively safe within their own little environment. Groups allow multiple users to have permissions to the same kinds of things. So you could assign 2 or 3 users to a group and allow that group access to a file or a folder that none of the other groups have access to. This is especially important with a server, in the fact that on a server you might have a dozen different accounts, and only some of the accounts need to be able to get to some of the files. That's about it for Module 2. And just to demonstrate a couple of commands, I have a terminal open here. This is in CentOS. If I start off, a lot of times I'll start off with just a print working directory. This kind of tells you where you are. ls will list the directories that are contained within the directory you're in. You can choose any of those to go to. So let's say I go cd home. Now I'm in /home. If I list from here, you see a couple of different options there. I can pick one of those and go cd as Ernest. Now I go into that. I can list from here. Let's cd desktop. So now I'm on my desktop, and if I list, you see the only thing there is test, but let's make directory new. Now I have a new folder on my desktop. If I do remove directory new, it goes away. That's just a couple of commands that are simple. There's many more, just a quick. And then during week 3, we talked about more specifically the Linux kernel, multitasking, the sudo command, and how to install apps. The Linux kernel is a lightweight kernel known as being a monolithic kernel. That means everything is contained within the kernel space, down to the drivers. That means that any of your applications, all of your compilers, your graphics processing unit, all of your in and output devices, their drivers are all handled within the kernel space, which allows for a faster environment. This can become more unresponsive if a app crashes. It can actually take the entire kernel down with it, but it provides the fastest environment. Linux primarily uses preemptive multitasking. That means it allocates slices of time to processes, allowing the kernel to know when the next process can take over and use the processor. This allows it to have some predictability to itself. The sudo command allows an administrative user to act as a root user to work at a higher level. This gives you more permissions. You see that there's a couple of sudo commands that are listed in the box below, but there's many more. All it does is it allows you to interact more directly with the kernel at a shell level instead of at the user level. Installing apps can be done a couple of different ways. Usually we can do it via the command line or the GUI. If we do it via the GUI, we're going to use an app that is connected to the repositories and lists out all of the other apps that it can install. Otherwise, we'd be using commands within the command line, such as yum install, things like that. grep will give you a couple different things. There's a couple of different commands that will allow you to install applications Either way, the action of installing an app is not too difficult, and it allows users to add functionality to the system. The process is similar across Linux, but Windows and Mac have their own kind of way to do each. They have app stores that are a little bit easier for many people to interface, that all host their apps individually. Usually, most of your Linux apps are not available on Mac or Windows. Most of your Windows apps have similar apps for Mac, and Mac apps have similar ones for Windows, but they are designed specifically for each. Just because you buy an app for one marketplace does not mean you'll be able to use it on another. So this has been a recap of weeks 1, 2, and 3, and I hope I answered all the questions. Thanks for your time. And last but not least, I'm just going to demonstrate a couple of sudo commands. So the first one I like is sudo bash. This will require a password. It just elevates me to being the root user. So from here, everything I do is more direct line to the kernel from the shell. Instead of being way out at user level, I'm down deep in the operating system now. Another cool one is sudo yum update. So it's going to try to update the database for the yum, which is the package manager. It says nothing's marked for update. Just a quick little overview of a couple sudo commands. There's a lot more. That's just a couple of them. And thank you very much for the time during this class. I've enjoyed it, and I hope many others have as well.